Hello ladies and gents, welcome back to another video. Today I'm gonna be explaining law of cosines. I'm gonna showing you guys the proof like I promised in the last video. Actually last video where I showed you how to use law of cosines in a really difficult problem. So yeah, so let's get into the proof. So we have this triangle, and I know it's a scaling triangle, but it can be any triangle. Law of cosines is always relevant in a triangle. It doesn't matter how it is, how it looks like. It is relevant. Let's measure this angle as gamma. And this is not y, this is gamma. This is a Greek letter named gamma. It's a third letter of the alphabet in Greek. And we have to prove the formula. C squared equals to a squared plus b squared minus 2 times a times b times cosine of gamma. In words, you can say a length of a side squared, in this case is c, equals to an other length of the side squared plus the other length of the side squared minus 2 times the other length times the other length times the cosine of the angle in between these sides, or the cosine of the angle opposite to the side we're looking at. So, in words, it is complicated, but in this equation, it is explanatory by itself. Okay, so we have this triangle again, and we have an angle of gamma. Now let's draw a height that is going towards A. So let's go. So this is the height, and this is 90-degree angle. And let's call this height H or hash or H. I don't know what you guys call it. You can call it whatever you want. Now let's move this triangle a little bit so we can write. This smaller triangle in this big triangle is an right triangle because it has a 90-degree angle. And we can actually write what cosine of this angle is in this triangle. So the cosine of gamma is the adjacent side, which is x, over the hypotenuse, which is b. So cosine of gamma equals to x over b, and we can write x as b times cosine of gamma. Okay, so now let's label this other segment r, and now we know that x plus r equals to a because they make up the side of a. And we can write r as a minus x, and we already know what x is in terms of b and cosine of gamma because x is equal to b times cosine of gamma. So let's move this up a little bit, and instead of x here, we can write b times cosine of gamma, like this. Let's delete everything here because it's kind of distracting, and let's move this up. So we have our first important discovery, that r equals to a minus b times cosine of gamma. Let's circle it with an explosion. On second thought, let's maybe put it in a box. How exciting. Okay, now, once again, let's look at this tiny triangle and look at sine of gamma. Now, sine of gamma in this triangle is the opposite side of this angle divided by the hypotenuse. So this will be h divided by b. And we can rewrite h as b times sine of gamma. That is really cool. So let's delete everything here. Let's circle it in a box. And let's move it up here. Okay, now we have two important things. What are we supposed to do with these? Well, let's look at this medium triangle. What is this triangle? What kind of triangle is this? Well, you're correct. It is a right triangle. And now we can write the Pythagorean theorem. So c squared, the hypotenuse of this triangle, equals to one leg, which is h squared, plus the other leg squared, which is r squared. And we already know what h and r are, so we can plug in these values instead of h and r. We're going in a little bit of spooky territory. So c squared is equal to this thing. This is absolutely outrageous. Okay, let's go slowly here. So this squared distributes to both of these. So this will be b squared times sine gamma squared. And this thing will actually distribute like this because of the a minus b squared formula. This is the same a minus b squared formula, but instead of a and b, we have a and b times cosine of gamma. Okay, let's move this up a little bit here and start speculating on what we can do. So what I see here is that b squared times sine gamma squared and b squared times cosine of gamma squared, these two things have a common thing, and that is b squared. They both have b squared. We can move this b squared times cosine of gamma squared here to make this more visually appealing. And we can rewrite this whole thing as b squared times sine of gamma squared plus cosine of gamma squared, because they have a common multiple. This common multiple will go out of this parentheses, and we will get an unexpanded format of this whole thing. And this whole thing will stay the same. So in this situation, we have to look at sine gamma squared plus cosine of gamma squared. Sine gamma squared plus cosine of gamma squared is actually equal to 1. And this is a whole other thing, and I'll prove it in the next video, and I promise. So sine of gamma squared plus cosine of gamma squared equals to 1. So instead of sine gamma squared plus cosine of gamma squared, we can actually plug in 1 here. So this will be b squared times 1. Let's move this up a little bit so it will be more visually appealing once again. And b squared times 1 is b squared. And to make this more visually appealing once again, let's move this a squared left. So it will be like this. And would you like that? We have proved the law of cosine. Let's delete everything here. Let's move this up here and let's put it in a heart. This is the law of cosines. And this is the proof. I hope you guys enjoyed the video. Make sure to like and subscribe, and I hope you enjoyed the video. Ding ding!